Hi, what you can hear and also see in front of you is my 555 Class D amplifier. You are listening to it through these speakers. I've got one over there too. The amplifier is powered by my power supply that's down on the floor, and it's supplying about 12 volts. And this is the amplifier. Now let me just turn it down. So what you can see here is, well, more components than one would expect, and that is because I've built the amplifier out of two 555s. One of them is over here, and it's generating a trigger signal used for the pulse wave modulation, and what you have here along with these two high power transistors is an actual 555 built out of its blocks. So in the middle I have a double comparator, I have a latch here, I have the power transistors that are driving the output, and here I have some driver for the high power transistors. I've chosen to build it out of its blocks because a normal 555 can only drive 200 milliamps, and that's, well, basically nothing for an amplifier. You can't make a reasonable power amplifier out of a simple 555. So I've made one of its blocks, and I've used 9 amps power transistors. They're a little bit overkill, but all the components here are what I had available, so it's probably not the best way. Now, as you can see on the oscilloscope, I've got a trigger signal on top, which is generated by the actual 555 that is here, and at the bottom is a pulse wave modulated signal that controls the output. So I've got the speakers here, they are both in parallel because I've only built one channel. I've got the audio coming in here and the potentiometer to adjust the volume. Since I have the supply back over there on the floor, I've used another filter capacitor here. Okay, now I'm going to explain a little bit more about how the circuit works. I'm not going to go into the details of a normal Class D amplifier, but what it basically does is to turn the speaker on and off with a very high frequency, and by adjusting how much time the speaker is on and how much time the speaker is off, you can actually create an average voltage that can follow your input audio signals. So what you get from the speaker is exactly the same as from a normal amplifier, with the addition that this thing is very efficient. You can actually see it's efficient because these two power transistors are dissipating very little power. I can put my hand on them and they are just warm. I've got a 555 here that generates very short pulses with a high frequency of about 175 kilohertz, and the 555 that I've built out of its parts should generate a pulse that has a duration of half the period of the trigger signal. Now, if I apply an audio signal to the actual control voltage pin of the second 555, the high power one, I can vary the duty cycle of the signal according to the music that I'm playing. So if I connect a speaker to the output, it will sound just like a normal amplifier. Now, things are a little bit more complicated than this. I'm using a filter capacitor at the output because I have only a single supply, so I don't want to let DC pass through the speaker. And I'm not using an inductor to actually filter the signal because the speaker itself is an inductor, and I get a reasonably good audio signal. Actually, it's much greater than I expected. So I have a actual filterless Class D amplifier. Now, in order to drive the high power transistors, I've built a small driver out of two NAND gates that are used as Schmidt triggers, and the reason why I had to build this driver is because I had to introduce a so-called dead time. If my transistors are both on at the same time, so I've got a push-pull stage here, and if they're on at the same time, I'm basically shorting the power supplies. So what I've done here, I've built a small filter for each of the drivers of the transistor, so that anytime a transistor needs to turn off, this happens as fast as possible. But when the transistors are turned on, they're turned on with a slight delay. That means that at no moment I have them both turned on, and this has been one of the difficulties of this project. Adding the AC audio signal to the control voltage pin of my high power 555 doesn't actually make the greatest solution for the amplifier, so I've decided to actually add a feedback loop. And right here in the corner I've got a dual op-amp. So one of the operational amplifiers just amplifies the signal coming from the source because I need a higher amplitude, and what I've got is a low pass filter that's filtering the actual output from the flip-flop. So the second operational amplifier compares this average signal to half the supply voltage, and what this means is that if I have a 50% duty cycle, I get half the supply voltage. So that operational amplifier controls the duty cycle of my high power 555 in order to have 50% duty cycle. If I am applying just the AC component of the signal to that half supply voltage reference, and so modifying it slightly, I actually get a varying duty cycle according to my audio signal. And now let's see it actually working. If I'm gonna turn on the persistence on my oscilloscope, I'm just gonna see how much the duty cycle varies when I turn the music louder. So we're just gonna watch how the duty cycle changes, and it's not that much, but if I turn it louder, so what you've just seen is that the duty cycle of the output signal is varying according to my music, but on top you can see the trigger signal actually stays the same. Let's talk a bit about the performance of the amplifier. In terms of quality, it sounds very great. It's much better than I expected it to be. It is actually missing some high frequency sounds because it's using a rather low modulation frequency, just 175 kilohertz. I've played a little bit with the equalizer, and I think it's cutting from about 15 kilohertz and up. But this can be fixed by using a CMOS version for the pulse generator and a faster comparator, but I've used what I had available at the moment. So just this topology can improve the quality by changing some parts. In terms of power, I'm using two 8 ohm speakers in parallel, so for a total load of 4 ohms it can actually have an output of over 3 watts. Now I know that's not much, but it's enough to listen to normal levels until it starts to distort. It's enough for a small room, but I can drastically increase the power if I'm gonna go from a single supply to a symmetrical supply. And if I can also build two of these and make an actual bridge for the speaker, I can increase the power and go to hundreds and more watts. And this is easy to do. All I have to do is change this driver to accept symmetrical voltages. And what I wanted to show by building this is that you can actually make a 555 Class D amplifier of reasonable power and quality that you can also make a 555 out of its building blocks. And of course, because it was way more fun than making a regular Class D amplifier with two 555s and adding a simple high power stage afterwards.